So does anyone have any questions about classes or anything else for that matter before we continue? Okay, so let's kind of briefly recap what we did with this money class. So we created a class called money, and we started out where inside the money class, this is like the blueprint for the concept of money. We had a variable for dollars, and we had a variable for cents. And then we were talking about making them private. When these are private, then it means you can only access those things from inside the money class. And we said that it's a good idea to make your variables private and then to add these methods that can get and set them. And so we had made public a thing like get dollars, so that from outside the money class, if you want to know how many dollars are represented, we could call this. And we had another one to set the dollars. So from outside the money class, you could set the dollars to something. And then we did the same thing for cents. And we said one reason for doing this thing where we have these as public is we could put some code into like the gets and sets to do things like prevent negative numbers, so you could restrict things to valid entries. So inside the set dollars, I had done something like right here, we checked if the amount of dollars coming in was pot 0 or more, then we set it. Otherwise, nothing happened. So we couldn't set like a negative dollar amount if we didn't want that to happen. So we can do some kind of sanitization inside these getters and setter methods. Another reason for doing this thing where you've got public here but private variables is if you ever decide to change these variables, then it makes it much easier. So for example, let's say that in the money class we didn't make these private, we made these public. And I'll leave these other ones here. I'll leave the set and the gets here, but you could pretend they weren't there. If we had made these public, then there'd be no reason to use these. Well, there'd be a reason to, but you might not use them because you don't have to. So imagine these are public, and then inside the code someplace we had a whole bunch of code where we said like money M1 and M2, and here's one where I did it for set dollars. So let's say we have a whole bunch of places where you set the dollars. And you set the cents. Oops, that's not to 199. So maybe we have a whole bunch of places where we've done this. Here I only have 2 places, but imagine I've got a giant program with thousands of lines of code, and I've got hundreds, maybe even thousands, well, probably not thousands, hundreds of places where I reference dollars and cents throughout my gigantic program. And everything might be working fine, but then one day we decide, well, we really need to represent more finely grained than just dollars and cents. So I know there are all these movies where like you have like fractions of a penny that somehow accumulate when you have interest rates or something. And so, maybe you want to keep track of something that's less than a penny, and you can't do it this way because we've only got integers for, a penny is our smallest unit that we can represent. So, well, what we could do is we might say, all right, we really shouldn't be representing this as 2 integers. What we really need to do is we need to represent this as a double. So you might say, okay, let's make this as like well, let's say it's public. So we decide, all right, we really need a double. It can represent 0.0000 whatever 1 pennies if we need to. And so this will solve our problems. But if we change the internal representation to a double, then now all the thousands of places where we represent, well, let me go back here. So this becomes a double, and we actually get rid of this. So the dollars and the cents go away. So now the problem is all of the other thousands of lines of code we've written that directly reference dollars and cents won't work anymore. And so we'd have to go through this effort of finding all the places in our program where you said dollars or cents and you have to change it. So instead, this would be changed to like, m1.amount equals 3.99. So that could be a lot of work to go through and find all those places to change it. But if we had forced everyone to use the set dollars and the set cents, then when we change this from two integers to an amount, then in the set dollars, all we would have to do, well, I wouldn't say all we have to do, what we would need to do would be to say, I'll just write it. I won't write the whole code out because it's a little messy. Well, I'll go ahead and write it. So what we need to do is set the dollars part of the amount variable to new dollars, leave the cents alone. So for example, if amount, so let's say amount currently, well, so let's say amount, for example, if amount equals 3.45, then whatever this new dollars is, we would like it to take the place of the 3, but leave the 0.45 alone. And we could do that. We'd have to do a little bit of extra work. So we'd have something like this. We would say like double dollar part. I can make an int. So if we take whatever the current amount is and just turn it into an int, they'll chop off anything after the decimal point. And so this becomes the current dollar part. And then I could do a double. So this is kind of like what most people did on the very first homework problem. Then I could figure out what the cents part is. The cents part would be whatever the amount is minus dollar part. So once you've figured out the dollars is 3, then you can take the 3.45 minus 3, and this gives you just the 0.45. So we've extracted out the dollar part and the cents part, and then we could say the new amount would equal the new dollars plus the cents part. So we replace the amount with whatever the new amount of dollars is, and then add on whatever cents we had. So essentially we've just replaced the number in front of the decimal point. So we could do, and then I wouldn't need to have, well, I could still do this, but I'll just take it out for now. So the idea is, if I change this from dollars and cents to amount, then I could write like mapping code inside the set dollars and the get dollars that map from the old way of the integer to the new version of the double. And as far as anyone outside of this class is concerned, like we would just still be using set dollars like normal and set cents and get cents like normal. And so from the outside perspective, everything would work exactly like before. But from the internal perspective, now we've changed it to a double. And so it's a little more work inside here, but it gives you that flexibility so that the outside world doesn't have to worry about how things might change inside the class. So that's another advantage of making these things as private variables. And so when we do this as a private variable, this concept is called encapsulation. So the idea is we've encapsulated the variables so they're kind of hidden from anything outside the class. All right, so having said that, I'm going to go and revert back to the way this used to be. But that's an example of where the private variables would be helpful for future code organization. Okay, so I just have a couple things I want to mention today. One of them is about a little more about methods, and then passing variables to methods, and then about constructors. So let's talk about methods first. So right here we've already got a bunch of methods, set dollars and get dollars. These are all methods. And we can pass in variables like this, where we pass in a new cent value. We can also pass in things that are not things like ints or doubles. You can pass in something that's another class. So for example, maybe I would like the money class to be able to take another money object and then add those two money objects together. So I could do something like this, public void. I'll make it void, make it not return anything, and I'll call it add money. And so I'll put a parameter here. Oops. So I have a method called add money, and it takes as input a separate money object. And so to indicate that it's another money object, the data type is money, and then I can pick whatever name I want to call it. And so let's make it so whatever the dollars and cents are for this other money object, we add it to the current one. So by current one, I mean we have something like this. Let's see. I'll just redo it. So we had done things like money M1, and then we said something like M1 dot like set dollars, for example. So when we make the method call, this is the money object we're operating on, and then this is the parameter. So in our case, this thing is going to be sent in as, let me copy it, add money. So when we call m1.setDollars and give it, well, let's not do set dollars. I'll say m1.addMoney, and then we have another one, money. And then in parentheses we give it m2. Then m2 is going to be sent in here as the other money variable. And then what we'd like to do is whatever m2's dollars and cents are, let's add them to m1's dollars and cents. So to even call this method, we have to call it in the context of some other existing money variable. So to do that, then inside this code right here, what I can write is something like this. I could get a new dollars, comma, new cents, and set new dollars equal to whatever dollars is plus other money dot dollars, and the same thing for cents. So when I have this, when it references dollars right here without anything in front of it, it's going to use the dollars for the object that we invoked the method on. So this dollars really refers to m1's dollars. And then this cents refers to m1 cents. And then this other money dollars refers to whatever m2's dollars is, and this one refers to m2's cents. So this will take the two dollars and cents and add them together. And then the last part we might do is check to see if our cents is more than 100 or greater than 99. And if so, add to the dollars. Oops. This should be new cents, sorry. So here, extra little check just to make sure we don't go over 100 cents. And then finally, I could set the dollars variable to new dollars and the cents variable to new cents. And this sets back, this goes back to m1's dollars and m1 cents, and it changes it to whatever the new amount is, where it's added in m2's dollars and cents. All right, so the idea here is you can send in more than just ints and strings and doubles and floats. You can send in other classes if you want. And if you send in another class, then you can access its variables and do whatever you want with it. Okay, so let's actually put that in here, and maybe I can copy it. New sense. All right, so now if I call add money, then it should add those together. So let's see if that works. I'll go back up here to main, where I made so M1 has $3.40, and right now M2 is $10.50. And so here we, after this line, if we say M1 dot add money and give it M2, then it should add M2's amount into M1. And then if we reprint out M1's info, then now it should give us $13.90 instead of $3.40. So there it is. There's our $13.90 where it's added them together. Okay, so we can add these. We can send in stuff as a class if you want to as a parameter. So having said that, there are some subtle caveats to this, and so let's mention those. And maybe I'll do it here. So if we have, I'll just rewrite it. So let's say we have some method. I'll just make a simpler one. Public void foo. And then over here inside main, let's say we do whatever my object dot foo, and let's, oops. Okay, so let's say we do this. I have like some other place like a main, and I have some variable, let's say it's y, and it's set to 100. And then we make some object whatever this method is inside. So whatever its class is, we make an object of that class. And then we call this method, and we send y in as the parameter. And so what Java will do is say, well, y has got the value 100. And so 100 gets sent in here, and then this should print out 100, and then x gets changed to 5, and then it prints out 5. And then this method exits, and so then the question is, well, here it's going to print y out. Is y going to be set to 100, or does y get changed to 5? Because, well, we had kind of tied the y to the x, and then the x got changed to 5. So two possible things could happen, and they're both probably equally valid if you were designing the programming language. Is you could say, well, since we change x to 5, and then x is linked to y, then you might say, well, y should get the value 5. Or the other thing you could say is, well, y just sent in its value, or y's value was sent in here, and then x is a different variable. You change x, that doesn't affect y, so then y should still get 100. So either one of those could happen. And so here, let's do it and see what happens. I made this class foo that doesn't do anything really but just have test stuff. So let's put it in foo. Or you could just put this in the money class if you want. So it's just to play around with. So it's a public void I'll call it test method call int x. So we print out x, set x to 5, print out x again. And then let's go out here to main, and inside main I'll make a foo object. So we have to do the new foo thing. And then I'll make another variable y, set it to 100, call my obj.test method call, and then send in y. NetBeans already knew I wanted to do that and put a y in there for me. And then we print out y. So let's run this. And what we get is 105, 100. And so if we trace through what happened here, the first print statement is coming from right here, where it prints out the value of x. And so that print out 100 because we were sending in y. Y was 100. Does that make sense? We change x to 5, and then it print out x, which is printing out 5. But now when this thing exits and goes back over here, when it prints out y, y still has the value 100. So y hasn't been changed. And so this is called pass by value, because the value of y is evaluated, and then that value gets sent in. And so at that point, y is completely independent. You know, y has nothing to do with x. X is a variable that only exists as far as this foo method is concerned. And any changes we make to x happen in the scope of foo. But once this thing goes away, this variable has its own separate value. It hasn't been changed. So, so don't expect these to change if you change them inside the method. Usually that's a good thing, because if you have a variable y here, you might expect it. This way you have like control over what values get in there, because you know that after this method's done, y would still have the same value as before, whereas if this could be changed, then who knows what it could be set to. All right, so having said that, there's a different behavior if we pass an object. So for example, let's do basically the same thing for the money object. So I'll go back here, but go to the money class. And I'll add in here in the money class, public void test method call. But as a parameter, let's say we're going to send a money object. I'll just call it M. So the difference here, we're sending a money object. We're not sending like an int or a double or something. So what if I do this? If inside here I set m.dollars equal to 1,000 and m.cents equal to 99. And then it exits. And so let's go back to our main over here. Let's get rid of this stuff. And so let's make another money object. I'll just call it test. And then we go ahead and we set test.setDollars to 1. And we set the cents to 1. And then we print it out. So I'll copy this line here. Change this to test. So this should print out 1 and 1. Whoops. But afterwards, we call test method call. And oops, I don't need to do test. Well, all right, I'll leave it like this. Test. It's a little redundant to use it twice here. Anyways, the way I set it up, I have to have some object here. So the main idea is I'm calling this method call, but test is being sent in as a parameter. I guess I could, let's see here. Look at that. I guess I could do it this way. Let me do this. So here I just made some other object just to show that whatever object I put here doesn't really matter. So I use test2. So the thing that really matters is I'm sending in test right here, and then inside the class, it's setting that thing's dollars and cents to 1,099. And so now if I print them out again, let's see what I get. So here it prints out first, I do the test, then I print them out again. So when I run this one, then you'll notice that down here it prints out 1 and 1, which makes sense because I set it to 1 and 1 and then it prints it. Then we call that method, and then I print them out after the method's done, but now the dollars and cents have been changed to 1,099. And so the bottom line is when you send in an object as a parameter, if you change the things inside the object, then those do get changed back in the place where it was called. So real briefly, in the notes, there's a lot more details about what's going on, but the bottom line as to what's going on is when we have something in here, let's see here. So the bottom line is when we do something like m1.foo and I send in m2, what happens when I create the m1, then m1 is really referencing some place in memory where it's storing that object, the money object, and then m2 is a variable that references some place in memory that stores its money object, and then they get set to whatever values, like 1 and 1 or something. And then when we make this call, when we send in m2, it doesn't make a copy of this whole object and send it in. It only sends in the address in memory where this thing is stored. And so x is really referencing the same place in memory where m2 is stored. And so now when x dollars gets set to 1,000, then it goes over here, and then this gets set to 1,000. So when this thing exits and x goes away, that reference goes away, but m2 dollars number has suddenly changed to 1,000. So you get different behavior with objects versus parameters with simple variables if you send in an object and change the insides of the object. If we said x equals a new money, then that would make x point to a new thing here, but then the original stuff wouldn't be changed. So it's only when you do like the class variable dot dollars or something that you change it back in the caller. Okay, so that's one of the other little subtleties. So the last thing I wanted to talk about, and this shouldn't take too long, is the idea of constructors. So whenever we made an object, pretty much the first thing we did is we set the values. So we made a money object and set the dollars to something, and you set the cents to something. In the last drill, you made a person object, and you set the name, and you set the credits, or a student object. You set the name, and you set the credits. So almost universally, the very first thing you do with an object is set some values in it. And so that happens often enough, like 99% of the time, that the designers of the Java language decided, let's make a way where you could create the object and initialize the values all at the same time. And to do that is called a constructor. And we've already seen one when we did the graphics example stuff. Do I have one right here? So when we did like this show image thing, we had public class show image, and then we said that to make this work, we had to make this thing right here. We had to make basically what looks like a method, but it has no return type. And then the name of the thing is exactly the same as the name of the class. And so this thing is called a constructor. And whenever you create an instance of this class, the constructor code will be run. So let's formalize that a little bit. So the constructor looks like a method, but there's no return type, and it has the same name as the class. And you can optionally add parameters if you like. And then multiple constructors are fine as long as they have different parameters. So let's see some examples with this money class. So I go to the money. So here in this money, I'll get rid of this test thing. Okay, so my class is called, if I go up the top, my class is called money. So to make a constructor for this class, let me get rid of this double Q. I would use the word public, and then the name of the class, money, and then left and right parentheses. And whatever I put in here would be run when I create a money object. And so maybe the thing I like to do in here is I'll initialize dollars. The default dollars maybe is $9, and the default cents is, say, 0 cents. But I can also make another constructor where I can pass in the dollars and the cents. So I can make another public money, but then this time I'll add 2 parameters, one for new dollars as an int and another one for new cents. And then inside here I'll set dollars equal to new dollars and cents equal to new cents. So what I've done is I made 2 constructors. This first one is called the default constructor because it has nothing inside the parentheses. And then this one is just an additional constructor. So let's use our 2 constructors. If I go back to the class main over here, let me get rid of this test stuff we were doing. So here I made a new money object, and I'll just leave this one alone. Let's comment these out. And then here let's make another money object M2, and I'll set its dollars to 10 and its cents to 50. So what's going to happen is for M1, since I didn't put anything inside parentheses, M1 is going to invoke the default constructor, and it'll call this code and set the dollars to 9 and cents to 0. And then for M2, it'll call the other constructor with 10 and 50. So 10 gets sent in here for new dollars, 50 gets sent in for new cents. That sets the dollars to 10 and the cents to 50. And so then I don't need to do these lines right here because this was done at the same time when it created the object for me. So now when it runs, this should print out 9 and 0 from the default, and then this should print out 10 and 50. So there's my 9 and 0 right here from the default constructor, and then this guy has 10 and 50 from the additional constructor. And then this is where we added them together. So it's recommended that you always make constructors at least to have a default constructor. So I'd say pretty much all the time when you make a class, you should make a default constructor, even if it doesn't do anything interesting, even if it's just there and it's empty. But whenever you have some fields here, normally you would add another constructor where you can set all of those when you create the object. Okay, so that's maybe that's a good place to stop for now. So all I have you doing for the drill is take the one that you did yesterday and then change it so it uses constructors instead of having to set all the variables. So it should run exactly like it did the other day, except using constructors instead.